Okay, so you're sitting in your Jupyter screen. I guess you've all seen this. So we're gonna just make a new notebook. Okay, then the plugin we're gonna use, or the module we're gonna use, is Sympy. So I'm gonna just say import Sympy as sym. If at any point you're looking at this going, I don't know what you're doing, just pause me and I'll happily explain. Okay, so we've got import Sympy as sym. Now that just means that anytime we use something from Sympy, we're going to use the prefix sym. Sometimes that can get a bit annoying, so I'm also going to separately import sine, cos, and pi, just because I don't want to, every time I want to use sine, I don't want to say sym.sine or sym.cos or sym.pi. So I'm going to import them separately so that I can refer to them in an easier way. Okay, now there's a couple of useful things in Sympy that I'm going to show you. I posted a link to the full Sympy tutorial, so if there's stuff you want to know about how Python can do symbolic linear algebra, you can just go through the tutorial, but I'll show you the sort of most useful things for the course here. So the first thing is we want to define our variables. So let's say we know in our calculation we're going to have theta. Then we're going to say theta equals sym.symbols theta. Okay, and you can look through the documentation for what's allowed, but most things are allowed. So you could say alpha equals sym.symbols alpha. That's just saying, create some variables for me that have these symbols. Now let's say I want to reuse this. I've imported sine and cos, so I could make some expression. I could say k equals sine of theta. Okay? And that would sort of keep the symbolic representation for me. So if I wanted to print it, let's say I said sym.pprint. That's how you sort of use the pretty printer. Sym.pprint k. And then you'll see what it prints out is sine of theta. It like converted the theta to a symbol for us. If we're in a Jupyter notebook, so this will work even if you're just using Python directly. You don't have to be using Jupyter, right? If you're using Jupyter, you have another cool function where you can say from ipython.display import display as disp. You've probably seen that syntax before. And then instead of using sym.pprint, we can use disp, which will use the Jupyter notebook features to do the display. And the advantage then is that it looks kind of cooler. You have basically latex formatting, and so that means you get your theta as a symbol. Okay, so that's kind of cool. But you can also then, if you want, do the calculations in here. So what Sympy will let you do is it'll let you substitute values in. So for instance, we could say k.subs theta, comma, let's say it's pi by 4 or something, pi over 4. And then set something to be equal to that and display that something, and we'll get the answer there. And you'll see it gives it to us in a readable way. Okay, I shouldn't have used L because L usually looks like the number 1. Let's use M. So we're displaying the output there. And if I wanted to instead convert it to decimal, I could just say sym.n, and then it'll convert it to a decimal for me. Okay, so I can use this to do the calculations in the course, and it means that I'm much less likely to make mistakes. But so far, while this is useful, it's not really amazing, right? But let's look at what makes it super cool. So let's say I have a transformation matrix. Let's say I have t0_1. I can say it's equal to sym.matrix, and then I can define my matrix in here. So let's say that this matrix is let's say cos theta minus sine theta 0, sine theta cos theta naught 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 1 naught 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 1. Then I could display that matrix. Let's say I displayed t naught underscore 1, and you can first of all see it formats it nicely. But I can also now do the matrix multiplications as well as the substitutions in here. So let's say I wanted you to convert that to decimal places, and I told you that theta is 90 degrees. Then what you could do is you could say t naught underscore 1 underscore maybe vals equals t naught underscore 1 dot subs. So that means make a substitution. Substitute for theta pi over 2, and then maybe also display t naught underscore 1 underscore vals, and then what'll happen is it'll give you the substituted matrix, right? Which is kind of cool. Like I say, it just means you're less likely to make mistakes. If I told you that t2 underscore 1 is equal to sum dot matrix maybe this one is cos alpha comma naught comma sine alpha comma naught and naught 1 naught and minus sine alpha naught cos alpha naught 1. Okay, that's an utterly random thing, right? Let's say that's what it was. I could then do and then I said, okay, so you've got these two matrices. You've got t naught 1 and t2 1. Find me t2 naught, right? Then to find or t naught 2, sorry, you could say t naught 2 equals t naught 1 times t2 1, and then you could display t naught 2 maybe. Let's take those out. And then the plus side is you'll get this thing out, and if you did this by hand, you're very likely to get some of it wrong. It's just it's just a very annoying multiplication to do. So if you do it in here, it's so much easier, right? You can then, given that you now have t naught 2, you can substitute values in. So you could say result equals t naught underscore 2 dot subs. Maybe theta is pi over 2 and alpha is pi over 3 or something. And then you could display the result and you'll get answers. Okay. Similarly, if you wanted to, you could change that to sum.n of result and you'll get decimal answers if you want them. Okay, so it's kind of cool because there's just like I said, it's easy to use. First of all, like it was quite easy to define our matrices, it was quite easy to define our symbols, and so in the context of a test where you have to do this multiplication, you can do it in here, get your result, do your substitutions. If you then you want to multiply this by p2 or something, you can just do it. You can just create that vector for p2 and then multiply it by this pre-multiplied by this matrix and get your point moved backwards. Okay, Why I'm mentioning this is that like it's always been available to do. I've never done a lesson on it before, but I do find that where most people lose marks is actually just on messing up the multiplication and not showing me enough steps. So then I have no choice but to take away marks because I don't know whether you didn't understand or because you did the calculation incorrectly, right? And I don't actually care about you doing the calculation incorrectly because, you know, you can always use something like Sympy. I care that you understood what you had to do. Okay, so in general, if you can use this, use this. Okay, are there any questions about this? Okay, you can all see how you'd end up using it in your kinematics tats and stuff. Okay, cool. I'm gonna leave it at that. Stop recording.